So as part of the intro, I wanted to actually also share this slide for folks that haven't been to the CNS and maybe you already are a CNS user and you're missing the labs. I wanted to share this picture of the the three labs that you might find me in at the CNS. The top one especially is the Geo6 lab, and it houses our prototyping tools. And if you see closely on the top right here, that is our 3D printer station. It's really just a bench with two 3D printers, but that's where we house them, and they are located in Geo6. The middle picture is our Geo5 lab, which is our cell culturing lab, as well as our EM prep lab. And the bottom one is the SMCR room, also known as our microfluidic fabrication room. And that's me on the bottom left. If you haven't met me, nice to virtually meet you all. And welcome again to today's webinar. So today I'll talk about 3D printing and specifically focusing on the FormLabs printers because that's what we have at the CNS. And also a shout out to my colleague Arthur. Thanks to him, he was able to remove the printers from the lab before everything happened, and I was able to bring those printers home with me. So that's why we chose FormLabs printers specifically. So the agenda for today will be a brief intro, a little overview on what is 3D printer and the different 3D printing and the different techniques that they're out there. I'll talk about the CNS printers, what we have and what materials we provide, what those can do for you. And I'll of course focus on the FormLabs printers that we have. I'll compare the two that we have, and I will spend a little time on the operational procedure because I was able to bring the printers home. I recorded a few videos that I would like to show you. They are short videos, so hopefully you won't get bored. They are short and they are up on YouTube. And lastly, I'll finish up with a few slides on the applications, and I'll finish up with the summary. So also in the bottom, I have this little timeline that you can see where what section I'm in the presentation. So what is 3D printing? 3D printing is a synonym for additive manufacturing, and that is really just making 3D objects by adding layer upon layer to create your final object. And essentially, it is when you bring an object from a digital form to a physical form. You can touch it and feel it. So 3D printing was invented by the gentleman in the right. His name is Chuck Hull. He printed the first object, and you can see that on the left, it is a little eye cup that optometrists use in their offices. He printed that out of his first SLA printer, and I'll explain what SLA is in the next slide. But after he printed that in '83, he filed a patent a few years later, and he founded his company, 3D Systems, and that is actually one of the biggest 3D printer companies in the world right now. So yeah, everything happened in the early '80s, and actually there is also some articles that say that Chuck Hull, like he filed his patent in the '86, and the Japanese were already working on additive manufacturing as well before him in their labs in the late '70s, early '80s as well. And also a French scientist was also working with that before. So they both filed for patents, but for some reason, they never went through, and funding reasons and so forth. So Chuck Hull, it is in paper, the father of 3D printing. So there are many different types of 3D printing techniques. I've listed a few on the left, but there's probably more out there. Today, I want to focus on just these three different techniques: bag polymerization, material extrusion, and powder bed fusion. Actually, they are the most popular techniques out there. So I'll go ahead and talk about those. And as I mentioned before, Chuck Hull came up with the first 3D printing, and this was actually an SLA printer. So SLA stands for stereolithography apparatus. And the way it works is you're using liquid materials, so photopolymers, and you use a laser to cure this liquid resin and adding layer by layer as the stage moves upwards or downwards. So there's actually two different common systems. The top, this is the bottom up method, and there's also a top down, and actually the first one was a top down system. So this SLA technique is what the FormLab printers are. So yeah, that's pretty much how it works. Now the next technique I want to talk about is the DLP technique, stands for digital light processing. And this is also part of the VAT polymerization type. You are using liquid resin as a starting material, but this time the laser passes through selective micrometers that are able to project what you're wanting to cure in the resin tank. So the good thing about DLP method is that you can, with one laser beam, you can cure the entire layer of your object. This makes it much, much faster than SLA, and also this makes it a little bit more expensive than SLA. So the next technique I want to talk about is, of course, the fused deposition modeling technique, FDM for short. And this is the most popular, most loved technique by the general consumers, by hobbyists that you see. So it works by melting a thermoplastic filament through a heated extruder. And from the extruder nozzle, you can deposit layer by layer the melted plastic that's coming out, and it hardens immediately once it touches the platform, the layer that is going on, and then it starts making your 3D object. So yeah, you must be already familiar with this type of 3D printing technique. Actually, they sell them, they're very affordable, and you can buy a DIY kit for as little as $100 or even less. So that's definitely the most popular one. Now I'm down to the powder bed fusion 3D printing technique, and the three of them that I'm going to talk about, they are very similar in the main process. So you essentially are using loose powder material to loose powder material. And if you guys see the top figure, I guess I'll just point out here, it uses a roller, and there's two different powder tanks, powder reservoirs on the side of the building platform. And the roller would put a thin layer of the powder into the working platform area, and once the laser turns on, it will sinter the layer that you're trying to make. Now when the roller goes on this side, now it is able to go and put powder, loose powder from the second tank to create the next layer and so forth. So this method is really popular with nylon material, PA11, PA12, mainly polymers. The next one is a laser sintering, laser melting technique that is highly popular with metals. So we are using, this is a figure that, it only has one powder reservoir, but you see them with two right next to the building platform. So this one, same thing, laser. The beam is guided to the working platform, and you're trying to sinter or melt the metal. So this technique is used a lot when working with titanium alloys, pure metals when you're using the laser melting. And here in parentheses, I have DMLS. It is also known as direct metal laser sintering. So I've seen, like people talk about them, and essentially the same process with those two acronyms. So the last method I wanted to talk about is called EBM, electron beam melting. So same thing, in this case, we have the powders powder hoppers and the rake in here. It uses an electron beam to center the powder and start creating the 3D object. But the main difference is that this system is entirely under a vacuum chamber. So that makes them, of course, more expensive. And this process is commonly used for creating titanium devices, implants in the medical industry. So you probably heard this question before. Is 3D printing changing the world? Especially, this question came up a lot in the 2010s to 2015, probably. So definitely lots of people thought so. 3D printing is definitely revolutionizing the world since then. We have lots of bioprinting companies that have come up and started, bioprinting organs, tissues, blood vessels. And this really started up, the 3D printing boom started up in the, 2012 was a big year. And the reason why is because all the patents that people filed in the 80s when they invented the 3D printers started to expire. So during those years, we saw lots of companies coming up with desktop 3D printers that were marketed for the general consumers like us and like research labs. And so definitely helped a lot in the biomedical research field, as you see on the left. Also, it has been seen in the construction world. Now we see 3D printing buildings, 3D printing tiny houses and houses. So this company, actually, I found out they're based in Boston, and they are making big buildings already. So hopefully they'll hope to help with the housing problem we have in the country. And then lastly, I wanted to add this picture in the right, because while doing research for this presentation, I found out there's this documentary on Netflix. It's a little bit old, from 2014, but I thought it was very informative. And if you're interested in 3D printing, I highly recommend to watch that. I mean, if you run out of things to watch on Netflix, you might as well watch this documentary. It was very good. They talk about the story of two main companies that were the startups really at this time. The challenges they saw when starting a 3D printing company, and also they talk about a few other controversial issues, like what should be 3D printed at home, what models should be out there online for people to download and 3D print. So I thought it was really good, and I wanted to share it with you guys so you can watch it later. So what printers we have at the CNS? We have a MakerBot Replicator 5th generation. It's an older model. It was bought in 2012 before I started working at CNS. And we have, for a long time, we had the Form 2 by FormLabs. This was bought in 2016 when I was there. And last year, we acquired the Form 3. So it was brand new in 2019, and we decided to get it to eventually replace the Form 2 printer that we had. However, I wasn't able to put it up there because everything happened, but that's the two FormLabs printers that we have. So I'll spend just a few minutes talking about the MakerBot Replicator. We have the 5th generation, which means it takes PLA material. The building plate in this replicator, it is a little bit larger than the FormLab build plates that the FormLab printers. And the layer resolution is 100 microns and can go up to 300 microns. If you can also go to 400, but we start seeing a little layer separation after 300. So I always say 100 to 300 micron layer height. On the right, I put this model from online. So this is an interactive model of a double helix DNA model. And it is a low resolution picture, but even in here, I hope you can see the little horizontal layers. This was printed with a MakerBot in white filament. And the pegs, the base pairs were also printed in a MakerBot with different color filament. Okay, so I chose this picture because this model will come up later on in the presentation. So a little more on the PLA material that we provide, because I am talking specifically about the CNS printers. We only provide black PLA plastic. And this is a question I get a lot because some people want, like Sandra, I want to bring my own filament. Can I just do so? And different colors, etc. So unfortunately, we are only wanting people to use the black PLA plastic that we provide because we used to provide several colors. We used to allow users to change them whenever they wanted to. And we started seeing a lot of filament clogging every time somebody printed, really almost immediately when making the first layers. So by just changing to one filament, one color, we actually improve a lot and we don't get those clogs that much. We often do, but it's much, much better. And we decided to go with the black color because that was the default color that lots of people wanted and needed. Lots of people are printing objects that would like to block light, and the black one was the one we chose. So it actually works pretty well with the at the CNS. So safety when using PLA plastic, PLA is really a safe material. Now, another very common plastic used in the FDM printers is ABS. And this does have a little safety hazard warning because the ABS fumes might be bad for you. So we used to have an old MakerBot that took ABS filament, and this one did have a housing that would keep all the fumes inside, so you don't breathe. So the Form 2 and the Form 3 main specs that you see are that it uses liquid resin. It has one light in the bottom, one laser located in the bottom, 405 nanometer wavelength. The layer thickness that you can get out of a Form 2 and the Form 3 ranges from 25 microns to 300 microns. And this really depends on the material you're using. So we provide clear standard resin, and that ranges from 25 microns to 100 micron layer height. For the build plates, really the Form 3, the only difference I would say that will matter when you're printing will be the height of the printer. So with the Form 3, you can get 0.4 inches taller prints, and that might be very beneficial for some people. The laser spot size is 140 microns for the Form 2 and 85 microns for the Form 3. Oh, I wanted to just quickly mention that the picture over there on the left is the same model that I showed before on the MakerBot, but this is the one that I printed with the Form 3. So as you can, also really hard to see in this picture, but you can see that the structure, the double helix structure is much smoother. The pegs I actually painted. I only have clear resin, but I painted on top, so it looks a little bit rough, but the main structure is what I want you guys to see. You can see the difference, how much smoother it looks like. So the FormLabs, the materials that we provide for the FormLabs printers are clear resin. Clear standard resin is what we have. It's the most versatile color that I thought would be best for the CNS, for users. It is great for fluidics, mold making, optics, lighting, anything you want to see through, pretty much. And FormLabs does provide a variety of materials. They actually have come up with lots of new materials. I was impressed by the list that they had. And I do want to mention that the uncured liquid resins that SLA printers use are toxic to your skin. They do have a safety hazard warning in there. So gloves and goggles are mandatory when handling any sort of SLA printer. So I wanted to include this, the data for the clear standard resin. solving compatibility and a few properties of the resin. And also I wanted to mention, so when you go into the FormLabs website, you really can't see exactly what it's made out of, and really is proprietary. But once you flip the cartridge, you see that they give you a little description there, mixture of the methylated monomers and oligomers and photoinitiators. So lots of people ask me what really is the resin made out of, and I just show them in the back of the cartridge. So the SLA printers do require a post-process cleanup. What we have at the CNS is this really basic IPA wash station, and this is what comes with the FormLabs printers. It consists of 2 tubs, and we fill them with IPA, and this is where we sort of rinse the outer liquid resin that has attached to the surface of the print once it comes out. It's coming out of a really liquid tank. So you do get lots of stickiness on your print, and you have to rinse them with IPA. So that's what we have available at the CNS. We put that kit inside the fume hood. However, I do want to mention, because maybe people already know that these 2 tools exist, but the Form Wash and the Form Cure is something that FormLabs has available out there. Unfortunately, we don't have this at the CNS, but it looks like it's really easy to just put the platform in there. It sonicates your print with IPA, and then you can immediately cure it. So the main differences of an FDM printer versus an SLA printer is that FDM doesn't give you watertight parts and is anisotropic. SLA gives you watertight, airtight parts. It is highly isotropic. And you can see also, and I put these 2 pictures so you guys can see again, but you can see visible horizontal layer lines on the surface of the print. And the SLA has excellent surface finish. The FDM also takes a little bit longer to print than the SLA printers. And this is especially for large objects. I noticed that for large objects, SLA is much faster. However, I've tested with smaller prints, and FDM to me was faster for smaller prints because it doesn't have to print the base and the supports that the SLA printer needs. So I always recommend, if you have a small print and you don't care which one you want to use, just do FDM. I mean, you don't care about your surface finish too much, use FDM for small prints. And for larger SLA, you get a much nicer, smoother object. Then the good thing about FDM is actually that you can customize the density of inside your print. So 10% infill density is what is default, and you get a nice lightweight print. And that's actually why most people prefer using FDM, because of it's really light. The PLA is very light plastic, so you can use that and use it for specific application that you need light plastic. But SLA defaults to 100% infill. You get a heavy part all the time, and you do need to use supports to hold that to the print because it prints upside down. So that's something to take into consideration when you want to choose what printer to use. And then lastly, the good thing about FDM is that you don't need to clean up after. As soon as it comes out of the printer, it is ready to use. You might need to remove the supports or the rough, but that's doesn't take any time. However, with the SLA printer, there is a cleaning procedure that you have to do, and you might need to cure your print as well. So now I want to compare the Form 2 printer versus the Form 3 that we have, and these are actually where the CNS printers are at this moment. They're down in my basement, and you can see the messy basement in the background. But the first thing you probably notice once you look at them side by side is that the Form 3 is a little bit chunkier than the Form 2. It is just a few inches wider, less than half an inch taller, and deeper as well, less than 2 inches deep. But to me, really, it is they're negligible. Like the dimensions are they're almost the same. If you could fit a Form 2, you can also fit the Form 3 in that same space. So yes, so the main differences inside between the Form 2 and the Form 3 is that they're both based on SLA, stereolithography technique. However, the Form 3 has this new specific type of stereolithography that is called low force stereolithography, LFS for short. And this is what FormLabs came up with when they were building the Form 3. And this has two main things that make the Form 3 an improvement from the Form 2. And that is one, it has a flexible film located at the base of the resin tank. And also it has a new LPU, light processing unit, that is located perpendicular to the tank, to the plate once it starts curing. So you can see this picture on the left. The LPU is that black box that you see there. And the flexible tank here, in this case, we're doing blue resin, so it's the blue one right here. So the reason why they decided to have a flexible film in the bottom is to reduce the peel forces between the print and the base of the tank once you want to start curing a new layer. So after the layer cures, the object has to detach to start the new one. And by having a flexible film, you see that it deflates upwards when the build plate is actually moving upwards and removing the object. So this helps reduce the forces of the peel forces between those two areas. Also, the LPU, you can see on the right, on the middle, that's a cross section of the box right there. And the laser comes out and it actually starts curing the platform perpendicularly to the laser beam. And that helps with better layer registration, which means that each layer can be cured exactly perfectly one on top of the other. And that helps making the print, especially if you're using a clear resin, more translucent. And that's the pictures on the top right is the contrast that you see between the Form 2 and the Form 3 objects come out. So much nicer translucency between the Form 2 and the Form 3. So the bottom right, there's just a diagram that I wanted to include of how the regular SLA printer works. That's actually from the Form 2. And you always get that angle. The beam always cures in an angle for that. So you never get that clear layer stacking that you see on the Form 3. So overall, the Form 3 makes faster prints, and I'll show you guys a little video later. And also has the ability to have light touch supports, which means that you can remove them with your hand as you could with an FDM printer. Before with the Form 2, they would have to be attached quite, you have to use wire cutters to cut the supports to remove them. But the good thing about the Form 3 is that you can use your hands to just remove it. You still get a little mark in there that you have to sand, but overall it makes the support cleaning process much faster. So I have this video, short clip really, to show you guys how the film actually helps, the flexible film. So I hope everyone can see this right now, but it is polymerizing resin there. And then once it comes up, the flexible film deflects upwards as well. So it's really good and it will give you better print quality and better reliability of your final object there. So I think that's really enough. I wanted to show you a comparison side by side of how the tank is different and what you can see below the tank. So the Form 2 tank has a clear PDMS layer in the bottom, and such as that, and it has a different type of mixer actually. Once you remove the tank, you see this glass. And if you see closely, I know it's probably not a good picture, but you can see the mirror here. The Form 3 has an opaque layer. So that is the flexible film that you see. It is not clear. It's sort of like an opaque white, a white matte color. And then once you remove the tank, you see a big hole in here. So actually when it's resting, the LPU system just is right here on the side. And yeah, I was surprised when I opened that and I saw just a big hole in there. So another improvement that the LPU gives the Form 3 is that now you can do much finer details to your prints. And this is from the FormLabs website. Usually when people ask me, what's the smallest hole I can make or what's the smallest channel, I send them here to this file. But this is, you can see here the different things, the different designs that you can make. Lots of people want to make some sort of channel or making something like this to use it as a mold. So the smallest you can do is 150 micron channel or 500 micron hole there. Okay, so yeah, just wanted to put this in here so you guys see that the Form 3 is definitely an improvement from the Form 2 printer. And I want to talk about now the limitations that I see from SLA printing. So of course, after it comes out of the printer, you have to rinse it in IPA. And this could take over 10 minutes, maybe a little bit longer. You have to air dry it as well. Because you know, you still get, I still feel a little bit sticky once it comes out of the IPA wash. So we recommend air drying it for a few hours just so it's dry enough and you know it's not sticky enough so you can touch it with your hands. It is overall a very messy material, and that's my personal limitation number one enemy. That any SLA printer, you get very messy working area. You also have to change gloves every time you have a little bit of liquid resin on your glove, because then everything you touch after that will have a layer of liquid resin. So yeah, that's the big limitation of SLA printing, in my opinion. Next, you have to use UV light to cure your print. This is mandatory for lots of the materials that FormLabs provides, but because we use clear standard resin, it is not mandatory to cure your print afterwards. But however, it can help. We don't have a UV curing system at the CNS. And then sanding support marks, this, after you cut your supports, you still, like I said, get a little bit residue in your print. So some people don't mind, if the support marks are in a place that you definitely don't care, in the base, let's say, then that's completely fine. You can ignore that. But if you want to sand it and make it smooth for a part that you really are using as a mold, or you want it to look much smoother, then you definitely have to sand the supports. So overall, it is, it takes a long time to have your print ready after it comes out of the printer, but it is definitely worth it to get that nice finish, nice quality print afterwards. So now I wanted to give you a quick tutorial of how to prepare your print to send to the 3D printer, and also what to do to get your printer ready and how to remove your part once it's ready. So these videos are short, and I pre-recorded the software tutorial as well, because the preform software tends to be a little bit slow once it's calculating the time, once it's generating the supports. So this way I'm able to speed up the waiting times that we don't want. So let's get started here. Okay, so I am starting just opening up the preform. It looks like that, the little butterfly logo that you see, and I already had it open. Like I said, it takes a few seconds to open up this software. I'm going to click on the settings window, and now I want to show you guys this. My software right now is connected to the 2 printers downstairs, but here it is, the Form 3 printer. It's called Wise Eel, and that is auto-generated by FormLabs. I did not name our printers like that. And now our Form 2 printer, certain goal, and it's telling me that the tank is inserted, there's a cartridge inserted, so that's good. I'm going to choose the Form 3 as my primary printer and select. Now I'm going to show you guys the list of all the different materials that you guys can choose from. At the CNS, we only have clear, so, and that's what I had here. I'm just going to select that. And from the clear resin, like I said, you get 100 microns, 50 micron layer height, and 25 micron layer height. So even in the small one, they give you a warning, make sure it is right, because it does take a long time, and sometimes it's not needed. You get really good quality with 100 micron layer height. So I'm going to open up my most recent model, and it is the double helix structure that I've been showing you guys. I chose this model because it is tall enough so you guys can see it coming out of the printer, and also uses very little material. It doesn't take too long. So that's how it looks like. Now I'm going to click on the first button to the left. It is called a one-click print, and the one-click print will automatically orient your print, put the supports, and choose the layout of your model. So this is when you really just want to, like set your print, you're in a rush, and you click on that and send it to the printer. And you are guaranteed a successful print. Now, sometimes, depending on what you really want from the object, you don't have to follow this. You can customize it later on. So, it's really up to you. More users most likely just customize their own later on, but for beginners, this is really good to start with. And you always most likely will do it at a 20-degree angle, 20 degree or something like that. And this is because it's trying to reduce the surface area per layer, just to reduce the peel forces that I mentioned before, and to make it a nicer, smoother finish overall. So the software is doing all the work for you in here. Okay, so this is the part that I said it takes a little bit long. So I have my timestamps here that I can increase. There you go. Okay, so it automatically opens up the send it to print window, but I cancel that. So this is what it looks like. This is what it shows, lots of supports throughout the structure and the base. Just showing you guys how the base looks and everything. So yeah. Now I'm going to, I'm waiting for the printability to be passed. And because I use one-click print, it most likely will come out as passed. And now I wanted to see how long this print will take. I'm going to click on the print time button to calculate the time. And let me go over here and show you guys that it's telling me that it will take 3 hours and 5 minutes to print this structure. Not bad and pretty normal for this size. Now I'm going to go on the left and show you guys how to scale up and down your printer. And actually, this is the part where I decided to show you guys that you can also do it here manually, right there on your structure. You can use that arrow to scale up and down and also move around your object. That sphere will allow you to orient your print to however you want, different angles, rotate them. I actually personally prefer to use the buttons on the left. So that's what I'm going to do now. I'm going to reset it back to the original size, and then I'm going to go to the orientation button. The orientation button, let me move that so you can see it, and I will put it in this orientation. So this is the way, like I decided to print it. it does have a thick base already within the model. So this was the best orientation to do it. In our case, we just needed to really quickly do it. So you can, messing around with the angles there, but just wanted to show you that you can do everything from these buttons. Rotating the model and just choosing what base you can have touching the platform. So that's really the same thing as the buttons, the box buttons in the bottom. So that's about it for the orientation. I will move on to the support button. And I decided to print it this way. And once I click the auto-generated supports button, this will automatically put the supports at this orientation. So this takes a little bit of time. I'm going to move it here. And there you go. So the supports there's not many supports. So you can see there, it looks pretty good. It's really holding up what it needs to hold in the structure, in the double helix structure. And that's what it looks like. I'm going to calculate the print time again to see the difference between the one-click print duration and this duration of how long it will take to print. So this one is quite fast, so I won't have to speed that up. But you can see there, 2 hours and 52 minutes. Not bad. So that's what it looks like. Now I want to show you guys that you can also edit the supports. If those little circles that you see there are where the supports are touching your structure, you can delete them. You can put more in there if you need to. And that's really, up to you. Sometimes some people don't want supports touching a certain size, so you can delete them. And also, if the software tells you need more supports in a certain corner, let's say, it will show up as a red shaded area on your supports. So here, the printability reads as pass, so it's good. And now it's generating again. Print that. So let me move to here. Oh, yes. So this is where I changed to mini raft. So you can see it significantly reduced the thickness of the raft when I click on mini raft. And you can see here, there's like holes in the raft whenever there's not supports that are holding up the structure. I'm calculating the print time again, and I actually decided to go with using the mini rafts for today's print. This is a new feature that they put in the software, but it is really just to help you reduce the time of your print. Let me just click, oh, it's actually there. So 2 hours and 44 minutes, and printability reads as pass. So it's all good. Then you can also customize the density and the touch point size of your supports. And here I'm showing you, that's the touch point size. So what is actually touching to your structure. So 0.5 is the one that will allow you to remove it by hand. It's really fast. And then you can also play around with the advanced settings. I never do, I always leave them as default. So the last button will be the layout button, and that will just allow you to create more copies and place them in your platform. You can also do it faster by clicking the array button and just place them like that. So I'm going to cancel and delete those two. And that's about it. So I am happy with this print, and I'm going to send it with this model, and I'll send it to the printer downstairs. So it is generating the print files. This part also takes a few minutes. but we're essentially done with the software. As soon as you are done, you can just go to the printer and set up from there. So the Form 3 setup, I have a very quick videos to show you guys. There you go, and hopefully the quality will be okay. So here it is after I'm showing you guys the cartridge. That's how the cartridge looks like. We have the clear resin, and that has a nice handle that you can slide back there. And make sure that the printer registers that you inserted a new cartridge. That's very important. Otherwise, the sensor, there's probably something wrong with the sensor. Now the tank, you generally don't have to change the tank or remove the tank right before print, but I just did that to show you guys. And that's the inside and the LPU system in there. So I'm gonna place the tank back in there and making sure that that says is inserted. So that's it, the two main components, and I'm going to click print. It always reminds you to open up the vent on the cartridge. So there, in case it needs to squeeze out more resin out of the cartridge into the tank. Now I'm going to put the build platform in there. So I had it out, but really should always be in there already. And since we use making sure that there's no parts in there that might have been stuck and sliding it back in there. So we only use clear resin, but if you are using the same build platform with different resins, you do have to clean it with IPH time. So that's it. And once you click print, it takes a little time to prepare, and you can see the LPU system moving underneath. That is the mixer. It's mixing up the resin to prepare it to print. And my dog makes a cameo there in the corner. Okay, so that is how you send your printer, how you prepare, start your print. Now I want to show you guys just really quick time-lapse video of the printer. There you go. This print actually took 2 hours and 44 minutes. And just show you guys how it looks like, because we're using clear, you can see the lights there, how it cures the resin, and now popping back up there. So it's a very quick print. Oops. Okay. And then how to remove the part once it's done. So that's the print right there. You unclip the build platform. Now I always twist the build platform really quickly because I don't want any of the liquid resin in the build platform to drip around the printer. You use those two tools to remove the print out of the platform. And because I use mini raft, it did take a few tries to remove it, but there it is once it's out. And I'm using the first rinse of IPA, and you have to shake, agitate this to try to remove the outer layer of the liquid resin. And then you move it and start the final rinse. So it's about 10 minutes. You can let it sit there for a little bit longer, but after a little bit of just drying in the room, you get the final print with the supports. So that's how it looks like after I remove all the supports. You can see the support marks in the base there. So it has to be sanded later, but that's good enough for me like that. And lastly, the last video I want to show you is actually a video of how we simultaneously run that same structure with the Form 2 and the Form 3. But we had an error in the middle in the Form 2 printer, so we weren't able to finish. I just want to show you them. We started the print at the same time, both printers, but both printers need to heat up the tank to 31 degrees Celsius. And surprisingly, we found out that the Form 2 was much faster, not much faster, but about 6 minutes faster than the Form 3 to heat up the tank. So that's something that I was surprised about, because I would think that the Form 3 would have would heat up much faster than the Form. Okay, so that's about it for the videos. I wanna again come back to my PowerPoint here. Applications. So as you can imagine, applications using a 3D printer are many, are infinite, depending on the material that you have, of course. But we have seen people using 3D printing in the education, research, world, entertainment, jewelry making, engineering, manufacturing, etc. So I want to focus a little bit on medicine and healthcare, because now during these times, 3D printing has come to be very important, especially with the COVID-19 response. Here, I have the NIH website, the 3dprint.nih.gov. And this is where they have lots of models for people to download and see. They have prosthetics, brain, heart models, and now they have FDA approved parts that you can print at home and donate. I also wanted to point out PinShape and Thingiverse. These are two websites that you can use to browse all the different models that people have made, and you can download the STL files and print them in your own printer. There's a few of the applications now using the FormLabs, the Form 3 printer. Form 3 came up with a new nasal swab and diagnostic test for the COVID-19 response. And these two, people that have FormLab printers can print them at home because they have to be printed under special conditions. But the reason why I wanted to bring the printers was to make the visor for the face mask to donate to the hospitals, our local hospitals. And this is what it looked like out of the Form 3. It was actually designed for an FDM printer, and you can make 4 or 6 at the same time. However, here is what it looks like in the Form 3. It is a very small platform, so I had to slant it ways, and then we spent lots of time, lots of material just creating the supports. And also it took 12 hours to make, really. So this is how it looks like without all the supports. And then I was able to find another design that could print 30 at the same time. So that one's much better. And then you still have to put the clear poly sheet on top to protect the face. And then lastly, for applications, now the Form 3, because of the better quality of prints that you have, you can create chips like this. And there's the new white paper that FormLabs has now, and you can get 2.5 millimeter channels or 1.1 millimeter channels in there. With other types of resin that are not clear, you can get, of course, dentures from the dental materials, the injection molding parts, jewelry with the castable material, and tough material. You have a carabiner here as an example. So in summary, 3D printing is additive manufacturing. You learn about the most popular techniques of 3D printing, SLA, FDM being the ones that we have. We have the MakerBot and the Form 2, and hopefully you learn a little bit more about the Form 2 printers. The Form 2 and the Form 3 printers, sorry. And you got to see a tutorial of the basic SOP that you'll use to send a printer to the Form 3. And then lastly, some applications, and there are many, many more applications out there. So these are my sources, and thank you. Any questions, please email me at my work email. And once everything is over, come visit me in Lisa G48. And please sign up for next week's webinar with Stefan. is going to talk about Introduction to Focused Ion Beam.